We're on lesson 5 of chapter 5, which focuses on congruence. We're going to write congruent statements. They're also going to use congruent relationships to find unknown values. First, what does it mean that two shapes are congruent? It means that the side lengths need to be the same. That also means the same angle measures as well. One thing it does not matter is position. So we could rotate these shapes, we could flip them, we could reverse them. Does not matter because as long as the side lengths are the same and the angle measures are the same, they are congruent figures. It's really important how you label congruent figures then. We see that we have measure 1 lining up with measure 1, measure 2 or side 2 with side 2, and then side 3 with side 3. Angle 1, angle 1, angle 2, angle 2, angle 3, angle 3. The order that we list the numbers with this triangle or any shape matters. So if I went A, B, C, I went angle 1, angle 2, angle 3. So if I said triangle ABC, if I was going to write a congruent statement, order really matters. And this is what congruent looks like. Since I went with angle 1, angle 2, angle 3, I need to go angle 1, angle 2, angle 3 over here. So I need to do D, E, F in that order. So ABC is congruent to DEF. If I would have said FED, that would have been a false statement. So here is a true statement. ABC is congruent to DEF. So let's keep that practice in mind here. We have write a congruent statement for each pair of congruent polygons. See, this one got flipped, as we can see, or rotated. So let's see if we can figure this out. We have KLM, for example, and the first one you do doesn't matter as much. It's the second one that really matters. So if I say triangle KLM, and if we're going to say it's congruent, which means I draw a little line on top here, what order do I have to go in to write this shape in? Well, you see that I started on the 94 degree, I went to the 21 degree angle, then I went to the 65 degree angle. So I would have to do that over here. 94 degree to 21 degree to 65 degree. So my triangle here would be RQS. So KLM is congruent to triangle RQS. If you use sides as well, that would work just fine. Side 2, side 3, side 1. Side 2, side 3, side 1. So that would be my congruent statement. These figures don't give us any side lengths, so this makes it a little trickier, although we can still use the angles to write this out. So remember, the first one doesn't matter as much as long as you're going in an order. The second one is when you really have to match it. So we would say polygon A, B, C, D, E. We're just going to go in order around here, A, B, C, D, E. And we're going to make a congruent statement, so equals or is congruent to. And now let's find out which way we're going to be heading this way. So I started at the 95 degree, and here I see the 95 degrees here. After that, we went to B, which is 135, then 80, 100, and 130. If you see this, we'd have to kind of go backwards here. 95 to 135, just like that, to 80, just like that happened. So we're going this way, to 100, and then to 130. So that's the order we're going to go. We're going to go around this way. So 95, 135, 80, 100, 130. H, I, J, F, G. So that's congruent to polygon H, I, J, F, G. And then that would be a true congruent statement. Now we can use congruence relationships to find unknown values. If we know that these two are congruent, we can solve these algebraically to find missing values. For example, it says quadrilateral PQSR is congruent to WTUV. And knowing that these names are in order can really help us solve them, because the shapes are not always going to be in the perfect position. As you can see, this one got rotated quite a bit. So this can really help us put these in order. So for example, if I need to find X, so where is X on here? X is between R and P. So between the last angle and the first angle. So where is the line between the last angle and the first angle on this one? That would be V and W. V and W. So there we have it. We can now solve X. This line and this line are the same. So if you're going to write an algebraic problem, X plus 5 equals, what's over here? 12. Then we could subtract 5 from both sides. So X equals 7. So 7 plus 5 is 12, which is the same as this congruent figure over here. Now we can find y. Y is over here. And I see that y is between t and w, or w and t. So here's wt here. And remember, name order matters, so I'm going to look between p and q here. So p and q equals 24. W and t equals 6y. So 24 equals 6 times y. Divide both sides by 6. Then y would equal 4. Now we only have one more to find out here. We need to find z. And z is over here in the angle. So I see z is angle v. Angle v is the final angle in our polygon name, which would be the r angle over here. I see that r is 132 degrees, so 11z equals 132. So let's write that out. 11z equals 132. Divide both sides by 11. And then 132 divided by 11 would be 12. So z equals 12. And we found all these different variables based on the congruent shapes. Just remember that if you follow the order of the names, you'll be able to find the matching lengths or matching angles, and then you can solve for your variables.